So welcome back from the coffee break. I know you want to spend more time chatting. Don't worry, you will have an occasion just when these two next panel are over. So I was not supposed to be here now. I was supposed to be on holidays after the intense work. But we had a person missing. Vanessa couldn't come because she got ill. So Bhanu, who was supposed to moderate this panel, just immediately converted me into the moderator. So I will do the moderation and ask question to Bhanu as a vengeance. I mean, at least I get to ask questions. So welcome back. Now, this is a panel which is entirely dedicated to open science because software is an important part of science. We heard this morning. And we are delighted to have with us today Claudia Bauzer Maceiro. You're here. She is a professor at the University of Campinas in Brazil. She's I don't remember your CV completely, but she's an amazing woman. She has been part of many significant organizations in ACM, in RDA, Research Data Alliance, etc. She had the responsibility of setting up the infrastructure for archiving data, but she is a computer scientist, and that's fantastic for me. So we'll get her to talk about software and not just data. So then we have very grateful for Christopher Marcum, who came from the US. He is in the office of the statistician, the statistician of the chief statistician of the United States. But actually, we had a chance to meet earlier when he was part of the Office of Scientific Technology Policies at the White House, who was responsible of publishing an impressive memorandum on open science for the federal organization in the US. And then we have Kaitlin Thaney, who is Executive Director of Invest in Open Infrastructure, which is a very important question about how can we maintain infrastructure for the common good. You know, the tragedy of the commons is looking at us every day. And Bhanu, Neupane, who you were supposed to be moderating, Bhanu is managing the program for ICT and open access in UNESCO. So the idea here is to try to see together the importance of software and open source as an enabler for open science and the different challenges that we can find. So how can we start this? Maybe I will start with you, Christopher, if you agree. Do you want to give an idea why open source is important in the work you are doing today?
No, absolutely. Roberto, first, thanks for the invitation. You know, the federal government, the United States federal government has the broad interest in open source and primarily from the portfolio that I managed, and I've managed both at OSTP, leading public access and scientific integrity, and now covering a huge swath of portfolio that ranges from artificial intelligence, cybersecurity, still scientific integrity and open science. Really, that scientific integrity is quite paramount to the public trust in the evidence base used to inform policy and decision making at the federal level, but also the jurisdictional and local levels as well. And often that evidence base consists of data and statistics or other analyses that are, have been developed and analyzed using software. And often that software is closed. And so you have a challenge then in really the sort of founding principles of scientific integrity, which is transparency. And so by fully disclosing the source code of those analyses, we can ensure that the public is able to very transparently see how that information came into being and has more assurance in the quality and integrity of that underlying base. So we really think that open source code can reveal that how underlying data were cleaned and processed, but also that's not just for the government use, right? We want to make it available to the public so the public knows how the decision-making capacity has been, from the data collection all the way through the decision-making pipeline.
Thanks a lot. So indeed, I mean, seeing from the public sector, this is actually, if I understand well, transparency, accountability, inspectability of what you do, reproducibility of this, and it's clearly rings a bell with us in open science completely. And now maybe, and then Claudia, moving to you, you have had significant roles in developing infrastructure for open data, for research data, yes? So you have seen the importance of software in developing such infrastructures. So software was a tool for creating the infrastructure to maintain data. Now, what do you think about the importance actually to have infrastructure for software instead of software for infrastructures up to now?
Okay, so hello everybody. Can you hear me? Thank you. I just to kind of show what I'm going to talk about very briefly. I work in Brazil. I'm a computer scientist, Roberto said. I am a data person, and I work from the top government level in committees to establish open science policies. I work for a funder where I helped create the first network of open data research repositories that involve 7 universities. In my university, I coordinate the open data research repository, and I suffer as a researcher from the policies that I helped implant and the infrastructure that I helped implant in my university. And one of the sufferings is that, first of all, it's all about data up to now in which I've been involved in, even though it's open science. But whereas everybody, when I mention software at all levels that I mentioned, everybody knows what it means. Okay, software. Nobody, when I talk about data, people ask me, what do you mean by data? Please define data for me. Okay, so that's the difficulty on one side. On the other side, since everybody knows about software, they have no doubts about what should be done. So that's, in a sense, a problem because software itself is still not being considered as part of it's everybody knows. I mean, everybody who knows what open science is in Brazil, which are not many people, but they think they know that software is important, but not how to keep it, how to maintain it, how to establish repositories. And in this sense, what I consider the most important factor in open science is really not software, is really not, I'm sorry to say that, the infrastructure, the data, or the publications. It's what I call peopleware. Because those are the ones who are going to implement, to develop, and to use. Okay, so how to change the culture so that people not only use the software, but value it, document it, and so on and so forth. Afterwards, I have a story to tell if I have time.
Okay.
Can I tell a story? No, I better let other people speak, but I promise a story.
I'm taking notes. So we will have the story. Absolutely. Yeah. So we have heard about the importance of software for transparency, accountability, etc. We have heard about the difficulty that Claudia is mentioning about software because everybody they know what software is, which I don't think they know much, but they have a difficulty understanding how to handle it properly. But then we have also an issue of how to actually sustain or maintain software. I mean, if you look at open science, a lot of infrastructure for open science have been built as open source software. Just let me mention a bunch of them. Okay, so you have the Open Journal System, for example, which is maintained by PKP, which is also supported by SCORS. It is a system for self-publication with all the editorial process that is spread all around the world. A friend of mine has been using it for decades for a journal in software engineering. You have other infrastructure which are, for example, you have Open Citation, more recent in Open Science, which is used to build the graph of citation, which is all fully open source and distributed. You have Moodle, we heard this morning, not this morning, just in the previous session about what happened through this call of the United Nations. Moodle is a e-learning platform which is completely open source. The fact that people could contribute to a new module comes from the fact that it is open source. But software, as you remember, it doesn't come out of the blue. It is written by people, and it is not free. I mean, you need to maintain it, sustain it. So, Kaitlin, maybe you can talk a little bit about the challenges and the approaches for maintaining these infrastructures.
Happy to. And it's interesting as well, because the comments, not only the conversations that have been happening today in the hallways and prior to the event kicking off, but also I'm thinking of Kate from the Linux Foundation's comments about open source being all around us and that we need to make it easy to work at scale. It's often this disconnect that we experience for the work that we do, where we focus on the infrastructure for research and for scholarship, the open source systems, the community developed systems that help making the accessibility of research and scholarship available more broadly, very in line with UNESCO's goals of having that equitable focus where all can participate, all can access with minimal burdens. And so, you know, the ties from open science, from open access, from open source are very much felt in the work that we do, but also understanding the complexity in terms of where communities view that investment most needed, where they feel that investment should be directed, and who's part of those conversations. And so IOI, or Invest in Open Infrastructure, came about from a literal hallway conversation. I'm going to look at Heather Joseph in the audience as well, who's part of those initial conversations, but from individuals that were really frustrated with what felt like the increasing scarcity of funds that were being directed towards supporting these open systems, which were getting more and more kind of vocal buy-in and understanding and, you know, awareness of, but also facing brittle sources of funding in terms of reliance on whether it's government funding, institutional contributions, philanthropies, et cetera, especially when you get beyond, say, the first 3 to 5 years of funding some of these systems. And you gave some examples of the Public Knowledge Project, many of the open repositories, you know, HAL is based off of DSpace, Fedora, the underlying systems, the open data repositories, the things that glue all those together that help with the discoverability are also all often based on, or at least there's more and more convergence that we are pushing for to invest in those open systems. They're more values aligned, but also from those initial conversations, recognizing that the scarcity of funding, the need for them, but also the consolidation, the commercialization of those solutions were leading to more competition among individuals that wanted to collaborate. And so IOI has its roots in a coalition of individuals that said, you know, we got to find a better way of approaching this problem in terms of the broader sustainability and the adoption, how we can increase investment, but also how we can be additive to the space. And so we, as an organization, we study the space. We look at where infrastructure for research and scholarship, not just in North America, not just in Europe, but in other locations around the world, where we can help increase the visibility of not only those infrastructures, those open source solutions, but also the complexities of where they are facing challenges, whether it is in-kind resourcing, financial resourcing, additional contribution, additional adoption that can help expand those services so they might be more robust, more viable, more embeddable in the fabric of how we conduct research and education. Not only surfacing those needs, but also then working with the infrastructures and with those that can contribute financially to and advocating for that financial investment to start to move beyond some of the models that have led to more challenges. And so I would say that, you know, one of the, there are many things I can say about this, especially in terms of, you know, where the fluctuations and where the brittleness in the funding landscape have adversely affected this work, as well as where the sort of, and for those that have worked for a long time in open source will be very familiar with the build versus buy sort of conundrum. You know, we deal with a lot of institutions, whether it's university librarians, IT departments, increasingly those on the research side. A lot of the investment in this infrastructure for research is carried by libraries in partnership with others. And I'd love to see more of them in this room, right? In terms of the not just financial commitments that they're making to support these infrastructures with ever shrinking budgets, but also the staff time that they put into place to take care of these infrastructures and move that forward, and the need that they have for more focus, more attention on that. But where the broader sort of implementation, usability, like it's complicated in a way that I feel like many in this room have started to make strides towards understanding movements forward, right? Like the embeddedness of software heritage in the conversations that we saw today. I'd love to see that attention focused on some of these underlying knowledge infrastructures at institutions that are facilitating research in the way in which we've all kind of spoken about and aligned values-driven ways, so that we can apply those learnings of bringing not just additional funding, additional attention, additional care to those underlying infrastructures, and find means of bringing them together more cohesively.
Thanks a lot, Kaitlin, for these comments. Now, I would like to ask you, Bhanu, a few questions, but let me start with an introduction. I remember when we were here in November 2021, UNESCO published this recommendation on open science, which was a result of a long work. Maybe you have some information to share how this worked, but I remember what was striking me is the fact that open source is now part of the definition of open science in this recommendation. And there was a second recommendation about infrastructure for open science that should be nonprofit, transparent, open to the community, etc. Because we have seen too many examples of things that have been closed down and made difficult. And so, of course, you want to see more of this. But if you want to see more of this, there is something we learned very early, that is, you cannot improve what you cannot measure. So maybe you could say something about the meeting that took place under your direction here a month ago or something a month ago on monitoring what is going on.
Yes. Thank you so much, Roberto. Just to highlight, what we did was just a month ago, we organized a conference here primarily to look at, if the open source can become a vehicle to monitor how open science is developing in different parts of the world. So this is something, what we did was not primarily open source as a component of open science, but something that would help better monitor open science. Quite interestingly, and this is something that I quote very often, that in the open science recommendation, which was agreed here about 2 years and 2 months ago, if I give the exact timing, free and open source software is utilized in that recommendation about 19 times. So it's extremely important in all possible contexts. So what we did was, about a month ago, immediately just run up to that conference that we had organized, we actually called, different people. We, in fact, managed to get about 600 people and randomly asked, they were all into open science. And we asked them, what are the 3 things, that bothers you most? Guess what happens? The first thing, they were not talking about open access, which is, I think, one of the major component as seen by the open science advocates. They were not talking about it. One of the first things, that they talked about was cultural shift and institutional barrier were the #1, constraint in achieving like open science. The other thing, that they said is something, that is very much, relevant to this group. Infrastructure and software for open science was the second. And the third thing that they mentioned was access to data for science. So in this order, they actually said that, like, unless, the mindset of the institution will change toward openness, the goal of, like real openness of science will never happen. So something, we have to do. So I thought about, like just coming out with something very much relevant to this group. Quite interestingly, the concern for open science has grown globally. 2022, I attended 85 meetings in different parts of the world that talked about open science, which was kind of open science or open data. In 2023, this number increased to 150. So I was, in fact, attending one meeting every second day in 2023. And if Heather is in this room, and if I will ask her number, her number will be about 450, if not more. So there is the concern has grown, but the concern has grown among those people who are already converted to the value of what open science can give to the scientists or the society. So here, I think, but we have got a lot many people who need to change. And I think, this is where we have got, Chris sitting here, and perhaps, that particular echelon of the policy making bodies, I think that's where, we have to make a big dent. Based on this, what we also asked them that, okay, if we look at from the free and open source software, what are the three things, you would like us to change? The first thing, that they said was, perhaps, interoperability needs to be better defined, because where the proprietary stops and then free and open source, quote unquote, comes to play, this is a very fuzzy, say, distinction. And perhaps, someone will have to better explain it to those people who are now, very much, almost, bought by ChatGPT. Even to draft an email, they would not, use their brain, but simply, can you please, draft a reply, and then the reply comes. Another thing, which was very interesting was the context of the licenses for free and open source software. That area is also, very blurred. And in fact, many people, ask that, can you provide us, with something so that open science community will benefit by, okay, this license allows us to go all out, but these licenses do not allow us to go all out. That's the second thing. The third thing, which was quite interestingly, is sustainability is a big challenge, for open source community. You may have a bunch of friends, get together and then say that, okay, let's in fact, create a software and release it freely. But what happens if one of the major person who is coding goes and joins one of the big tech company? He finds a job in Meta, and there you go. Your entire work comes crashing down. So what to do? And so sustainability is the main issue. And in fact, the community request if there is an access to some funds, so that some of these people who are maybe coding in the basement apartment can somehow be sustained to serve the larger open science community. I will stop here, and then perhaps I will provide more response later. Thank you.
So, Chris, I would like to give you back the floor, because I think you have many things to say, but I do not want to limit what you want to say. So then I just give you back the.
I think this is really really apt and kind of relevant to what my talking points were going to be anyway. And particularly this as you mentioned about the balance, sort of the conundrum between build it or buy it. And I can actually I'll skip through some things. I did prepare some slides. Oh, maybe I didn't.
Yeah, okay. Wait.
Somebody can say, but I won't go through them all. But I will. There are a couple of relevant points that we've discussed, directly here, and from the perspective of the U.S. federal government, which is what I was asked to provide some thoughts on in terms of how open source software fits into this sort of a broader federal ecosystem in the United States. And briefly, basically, the U.S. federal government, right? In 5 key ways we interface with open source software. There are lots and lots of developers of open source software in the federal government, which brings up this point about the licensing, because there's agencies have federal agencies, it's a very federated system, have a different interpretation, right, about the licensing aspects, because if it's developed by the federal government, then the one interpretation, the sort of the strong interpretation, is that that code should automatically enter into the public domain. It's not subject to copyright law. There is no license for it per se. It sort of transcends the licensing requirements because it's public domain. We share it, we use it, we fund it, and we archive open source software. I'm going to skip through some things because I think we've covered most of what I was going to mention, Roberto, here. But just to point out that we have some very large, even though this is only 78 followers in the U.S. Census Bureau, they have a very large repository of their source code on GitHub. And I was going to use the federal statistical system as a lens through which to sort of look at how rich this environment really is in the U.S. The big thing here that is relevant for software heritage is that by U.S. policy, federal policy, and you did mention at least one of the executive orders earlier, we are required, federal agencies are required to share their open source code. That is policy of the United States government, and they're required minimally to share the metadata associated with a repository for that code on code.gov. And so you can see a very large archive of the metadata for that code. I don't know what this means, but I don't. Something went wrong. Something is always wrong with this. If only we had really reliable open source software instead of the proprietary software that they required me to use to develop these talking points, none of this would happen. But I was going to actually point to this is somebody else's presentation. I was going to point to is the policy document. So the last slide here, if you just skip to that, maybe. This is so apt. This is a problem that you should be funding to resolve, looking into resolve, and that you can build, right?
You can find me at the break.
They're out of memory. But what I was going to point out, regardless of the infrastructure not supporting the PowerPoint slides that we've developed, is that, right here, next slide, very last slide, maybe, yeah. So there's a whole slew of government-wide policy that interfaces with open source software in the U.S. federal government, and some of this is sort of historic. It's been a long time in the making. You pointed out in your opening statement, Roberto, the executive order on cybersecurity. We also have the recent executive order on artificial intelligence, and that references directs our office, the Office of Management and Budget, to develop guidance that was put out for public comment. And we directly reference open source software expectations for the artificial intelligence, use of artificial intelligence by federal agencies. The 2022 public access memo, as you mentioned, directly, almost immediately after we released it, there's no mention of open source software here. That was intentional because we wanted to give agencies a lot of latitude with which they could interpret the data sharing requirements, and many agencies have included open source within their interpretation of data sharing. And so when we say that you need to share the data necessary to reproduce your results, well, that will probably include the pipelines. And so agencies like NASA, for example, have a very strong statement. The Department of Energy has a very strong statement. So I just want to say that there's a whole ecosystem with respect to policy that involves open science here that directly relates to the interface with open source. And that's all. I'll stop there. So I wanted to, because I think we touched on, and we were helped with the software and infrastructure that we had to touch on some of those points today.
Thanks, Christopher. So my apologies. This is not my machine. And next time we use my machine.
It's the finest technology UNESCO had to provide.
Oh, that's what. But I don't criticize our cost. I mean, it's absolutely. But so thanks a lot for this. And actually, I have to say, I'm really impressed by what the U.S. government has done in the past. You know, the reason why we have access to the source code Apollo 11 is that if you look at on the top, it is saying this is in public domain because that was the interpretation back then in the 60s. Otherwise, we wouldn't have access to that.
And I'd say the public domain, I mean, again, this is really part and parcel to should we build it or should we buy it? And one of the reasons that we have these policies, right, for the federal government is that when we fund open source software, when we develop it ourselves, it reduces redundancy for the agencies themselves. So there's an issue with replicability. Well, if an agency's already built it, then another agency should probably use it, right? And so that gets us into this situation where we don't want to continue building the same thing over and over and over, which has been a challenge, and it continues to be a challenge in the community. I think if you go onto the R, if you go to R, I think there's probably 7 or 8 packages that just do canonical correlation analysis. Well, why is there 7 or 8 packages when, you know, there's one core package that was probably sufficient? And that's sort of one of the challenges that we're trying to address with the archiving.
Yeah.
That's a very important point. I mean, discoverability of what already exists, understanding the quality, etc. You know, opening a parenthesis, this is one of the challenges we are trying to address in Software Heritage to try to, I mean, since we have this kind of a large telescope on development, trying to find the proper information about the software which is in the archive would help later on to find the kind of library or component that you actually want that maybe exists already. But in many cases, it's easier to rebuild it than to find it. And we want to avoid that as much as possible. And so, yes, I'm remembering. Claudia, you had the story to tell. I mean, let's see the story. Let's hear the story.
I have a story and a poem because I'm a computer scientist, okay? So, the story actually is about when I was listening, and this is all related to someone talking about why document. It was a biochemist, a US biochemist, and he said, I document for reuse of my future self. Okay, so you're not just documenting it for others who are not yet born. And then I thought of what happened to me, which I used in a couple of talks on open science, and people like it. A few years ago, I had a collaboration with a German scientist in Bremen, and he said, I'll send my student to pick you up at the airport. It's a small airport. I arrived, nobody there. They were going to close the airport, and there was I with this person walking up and down with a sheet of paper on his hand, and then he approached me. It was a printout of my web page with my photo. And he said, is this you? And I said, yes. And he said, you changed a lot. Now, however, the story goes, I mean, I remember that this, the first time I told it, I had not planned it today. I planned to tell it. My web page is fair, okay? It's findable, it's accessible. It's in HTML. The photo is in JPEG. You can open the code. So being fair is very important, but it's not enough. It has to be documented and also documented for context. I want to keep that 30-year-old myself in my page because I like it. That's the way I look when I look at myself in the mirror. I don't want to look at myself in the mirror today, okay? And so think about it, documenting for others, but for you to reuse, and context on the way of reuse and repurpose. And since I know we don't have much time, I'll just repeat part of this poem of a poet called Paul Valéry. There is a museum nearby, the Tour Eiffel, which is called Museum of Man. And Paul Valéry, when it was constructed in the 20s or 30s, he was told that he had to write a poem that would fit the frontispiece. So many letters, okay? And he wrote a beautiful poem for that museum in which I select the following. It depends on whoever passes by me, whether I am a tomb or a treasure. Okay? Whether I speak to others or whether I don't speak at all. That depends on you. So software heritage and the software archive is a treasure. But unless you understand the nature and unless you reuse it, unless you, take advantage of this treasure, we have to make it very clear to everyone that's a treasure and not a mere repository to be buried as a tomb. So thank you very much for being here. This was, I mean, still going to be a wonderful event. Thank you. Don't forget to look at my webpage and tell me I have not changed at all.
Thanks a lot, Claudia. Yes, but yes, I hear what people are saying. There are many things that have been said here. I mean, if you want to reuse, if you want to adapt, if you want to maintain, you need to understand. And you have seen this sheer amount of information, of code that is just in the archive we are maintaining now. It's not easy to look at. We are developing technology. We have seen some of this technology to help. I do look forward to maybe we had seen code generation, but what about research augmented generation in the future, helping us finding what we need in what is already there in efficient way, much more efficient what is done today. Let's see if we can get there. So I think we only have a few minutes left. So now Kaitlin, I'm going back to you. What do you think after this crazy panel with stories, etc.?
Well, and I know in planning for this panel, you'd also asked for like explicit takeaways that we can call for. And I know, and I'm more than happy to talk in the breaks about some of the complexity and some of the ways in which we're looking at interventions that might be able to move past this work, or some of the challenges in the broader sustainability, which I know Bhanu has been embedded in many of those conversations. Many of us have, because what we have seen is that it is, yes, more funding, more resourcing is needed, but also the adoption and the use of these tools, as anyone here who's contributed to a project or helped to support embedding that in a broader system can tell. And I think that that element of understanding that this is a shared responsibility is something that we are working actively to try to move beyond the usual suspects that are funding some of these infrastructures and funding the creation of infrastructures that have been created before rather than the implementation. Like the interoperability challenge is very difficult, but we are also facing, even with open solutions, a proliferation of tools and offerings that are becoming difficult to sustain in the way that I think it kind of goes against the initial vision for that. So I'd say just my parting words for this group is, if you rely on any form of open research in your work and research and development, it's part of your process. Think about not only what systems you're utilizing, where there may be open alternatives that you can utilize, and also what sort of way of giving back you can start to move towards. Whether that's in terms of your company, organization, institution, linking with another group at your library or research department or what have you, because this needs to move beyond thinking through governments just supporting or philanthropies just supporting, because they are unable to sustain over the long term alone that work. And that creates a kind of instability and keeps us from achieving this broader work. So that's my invitation for you all, is to think about that. I am always happy to support, and just my immense thanks and also congratulations to Software Heritage for leading the way.
Well, thank you, Kaitlin, if I may. I mean, what you are saying reminds me of a key point. I'm old enough that I was part of the open access movement many, many years ago. And I remember that was a moment, when the internet came around, if I can take a few seconds to tell you a story this way, the partnership between traditional publisher and researcher was a marriage of convenience before the internet. Okay, that was the most efficient way of distributing our work around the world, was through commercial publication. It was okay. Okay, so everybody had their interest. And then the internet came around, and there was this promise that, through the internet, just put this on my webpage in 2 seconds, it's available to the rest of the world. So we were expecting the world to change completely, to have one infrastructure for publishing, archiving, referencing, paper indexing, etc. The wonderful work. Unfortunately, we didn't do it right. And the result is today, if I'm not wrong, I remember seeing some statistics in the Committee for Open Science here in France. there are more than 12,000 different open access repositories across the world. 12,000 different repositories. So each, and in France, no. France is more top-down. So we have one repository, which is HAL. I mean, French people do it right. But but if you go in Germany or in other places, etc., they have one repository per institution. So this means one data center, one engineer, one backup, one whatever, one metadata schema. And if you have a paper written by 40 people, maybe you have 30 copies in 30 different places with 30 different metadata and not exactly the same paper. This is not what we expected. Okay, so of course, I mean, politically, we say, no, it was not a failure. I mean, this is just a distributed infrastructure, and then we create a federation on top of it, and it's a kind of this is a very nice political way of putting things. Okay, it's you could also say a big failure in planning. Now, what we try to do here with Software Heritage, with much more limited resources, is to try to avoid this tragedy for software. This is the reason why Software Heritage is designed to actually archive all software, not just the one from the US or for France, not just the one for research, not just one for physics, not just one of industry, all software, because it is a common infrastructure. Archival reference is a common need, and try to communicate with, and partner with all these community in different ways, because, and now I will be hated by all my friends in open source. I mean, open source by itself has no value. Wait. I'm saying open source technically means you use an open source license. If having an open source piece of software means it is immediately of value, quality, etc., that would be fantastic. I take any lousy piece of software, slap an open source license, and all of a sudden all the bugs disappear. Okay, no, of course, it doesn't work like that. So you need to avoid balkanization, check quality. So at some moment you also need to make decisions when you fund. Okay, so how do you make the decision? So at least for this kind of infrastructure, we try to provide one infrastructure shared with everybody, instead of having 12,000, 14,000 individual repositories in the future. Well, sorry, but and we are running out of time. So sorry, I wanted to say something that I think, and maybe Bhanu, you have a final word?
Yes. In fact, if I may, just understanding we're almost running out of time. One thing that this community has to do is to provide at least two good indicators that the community around the world, can use, and especially the member states around the world can use to measure how much free and open source software is driving open science agenda in their country. And this is absolutely important for us to develop.
Okay.
This is not only in terms of how many they are doing, but how much they are using it to produce science in their country. So this is absolutely needed. Thank you so much.
Okay, thanks a lot, everybody. I'm sorry again, I was not prepared to manage this roundtable, but I hope we survived the exercise. Okay, thanks a lot, everybody. And we move forward. Where is Fackson? I'm so happy to give you the floor. Thank you.